Today we are solving the problem of the minimum points to reach a particular destination. So this is basically a problem of dynamic programming, and this problem basically has an accuracy rate of 33% as per the all 28,000 submissions, global submissions of today. And the problem you can see is among the hardest problems. So it is also given as hard. So this problem is an important question which took me an hour or a couple of hours to solve it, because I'm initially working with DP hard problems. And what I came to know is that I have studied this problem somewhere before even, and I was like a bit confused where I studied this problem, and it was looking as a known problem. So when I looked up, so this problem basically is a lead code dungeon game problem. So if you know what the dungeon game problem in lead code is, so basically, it is the same problem over here as this one, the minimum points to reach destination. So let's go with the problem given in GFG first, and then I will come to the dungeon problem. And our solution will be to solve both the problems, because both are the same problems exactly, and to understand and have a very clear understanding of how this problem has to be tackled. And in your interviews or in your coding round, if questions like this come, and how you are going to perform. So let's go with the question. The question says that given an m cross n grid, or you can say an m cross n double dimensional matrix, with each cell consisting of positive, negative, or 0 point. So you can see for the sample values, it is a 3 cross 3 matrix, and it has all different type of values. So the first value is basically -2, -3, and 3, which is negative, negative, and positive. The second value is negative, negative, and positive, and the third value is positive, positive, and negative. So whenever we move across a cell, we have positive paths. So they are saying that we can move across a cell. Suppose I have made a document where I'm visualizing the array or the matrix. So I'm moving from this path to here. So I need to follow a positive path. Okay. So this is rule number one. Next, what we are saying is, like, whenever we pass to a cell, in the cells are added to our overall points. So suppose we are finding a route which is the shortest route to this particular cell. So we have to, the current cell plus the most optimized solution between the two adjacent cells. So this is how we are going to calculate the route. Next, what we are saying, that our task is to find minimum initial points to reach m minus 1, n minus 1 from 0, comma 0. So what is m minus 1 and n minus 1? So if let us write like this, let me change. M minus 1 is equals to m minus 1, n minus 1 equals to minus 5. So how is this minus 5 coming? So basically, suppose this is a 3 cross 3. So 3 minus 1 is 2, and 3 minus 1 is also 2. So 2 comma 2 coordinates. So minus, so which means this particular coordinate. And this particular coordinate, we can highlight it as, say, a different color, say blue. So this particular coordinate is the most bottommost corner cell. So we have to reach such a way that we take the minimum possible number of points. Okay, so we can move like from 0 to 0. So we have to start from here. So this 0 to 0 we have to start. So where was I? Yeah. So was discussing the problem where you can see there are a lot of coordinates available over here, and we have to reach from the like 0 comma 0 coordinate. So the 0 comma 0 coordinate is basically -2, because I have in yellow and highlighted regions, I have marked the coordinates which are denoting the positions. Suppose 0 comma 0 is -2, 1 comma 1 is -10, and 1 comma 2 comma like 1 is 1. So in this way I have mentioned all the coordinates in the highlighted regions, and we have to find basically the starting point is this one. So let's give a color for this one as well. So we are starting from this object start, and this is end. So we have to reach from here to here in the minimum possible number of points, using the minimum number of points. So I will do a DP calculation table, because in order to understand how to reach there, we have to do a DP calculation table, and then we will correspondingly check our output. So the approach which we are going to follow is a bottom-up approach. So I can write over here the, the approach like we are going to follow is a bottom-up approach. And the reason why like we are using a bottom-up approach instead of a top-down approach or a recursive approach, and why we are using dynamic programming and not just, we are not using any other thing, why we are using dynamic programming. So the reason is optimization. So there is, in the end of the code, they are given us expected time complexity of nm and space as nm. So in order to achieve this, the dp is the only and is the fastest possible way we can reach this. You can check the topic tags, they comes under dp only. And the company tags, Microsoft has given these questions as well. So we have to do is we don't need to read or print anything. We have to complete the function which takes m and 2D vector points as input parameters and return the minimum initial points from this to this cell from 0. So in order to reach this cell, which is the m minus 1 n minus 1 cell, to minimum points to minus 2, which is 0 comma 0. And this is a bottom-up approach of a DP table. So let us calculate the DP table first. Only then we can solve this problem. So let us do. So it is saying that 7 is the minimum value to reach the destination with positive throughout the path. If we have given a matrix which I have taken over here. Below is the path 0, 0, 0, 1, 0, 2, 1, 2, 2, 2, and blah, blah, blah. With finally we have 1 point, so greater than 2. So basically you will not understand. If I explain, if I tell you the explanation of this particular problem, you will not going to understand in the first place. So we have to make a DP table in order to understand this. Suppose we have minus 5. Okay. So when we are having minus 5, the condition is we can move to the left or we can move to the up. So when we are moving to the left, so we can see 30 is there. So what value is required in order to make it minus 5? So in order to make it minus 5, we have to use, we have to take the present value of the cell, which is 30, plus the value which we are going to reach, that is minus 5. So this becomes 25. But we know, like, any positive value, whenever it is any positive value, 25 can is a is a say is a positive value. So we can take it as 0. So we can write it over here as 0 as the, because 25 is a positive value. So we are making points for our reference in order to reach this particular point. Okay, we can take it as 0. So next come to the next point, which is 10. So we can see the, in order to reach 10, which is the next adjacent cell or the cell denoting 0 comma 2. So in order to reach 2 comma 0 or 0 comma 2, whatever it is, so how will you reach this point 10? So basically you have the current value of the cell, which is 10, plus the minimum value which we can reach is 0, or the 0 is the the next adjacent value. So in order to reach 10, we have to do is basically we can take this as 0, because only 10 minus 10 or can become 0, right? So any value which is there, positive value, we can take it as 0. Now let's consider moving a bit upwards. Okay, so when we are moving a bit upwards, we can see that 1 is there, okay, and minus 5 is there. So how we are going to reach from 1 to minus 5? We have to obviously add a value, right, which will make it minus 5. So what we are going to basically do is we are going to do 1 we are going to do is basically we are going to add plus 1 to minus 5, so which will become minus 4. So this is how we are getting a minus 4, right? So again, when we have two options, right, we can move to the left and we can move to the top. So while moving to the left of this particular matrix, we can see that we have encountered minus 10. So now whenever we are doing this particular cell, which is the cell number is 1 comma 1, we have to take the minimum value of these particular two cells. Okay, so we have to take the best optimized value. So greater than, if you see the best optimized value, minus 4 and 0 both are present. So which is the higher value? 10, 0. So right, so 0 in or add, we have to add with minus 10, so this will become minus 10. I hope you understand, because what we are basically taking is maximum of down and right. So you can say over here as maximum of d comma right. So that's how I'm getting minus 10 over here in the DP table. So this is minus 4 and this is 0. So the maximum of 0 and minus 4 is what? 0. So 0 plus the initial value of the cell, which is minus 10. So 0 plus minus 10 is minus 10. Okay. Similarly, now what we are going to do is we are going to calculate for minus 5. So how we are going to calculate for minus 5? So in order to make this minus 5 reach over here in this minus 5, what we have to do is we have to very carefully think. Okay, so what is the initial value of that particular cell? So the initial value of the cell is minus 5, and we have to reach minus 5. So how you can do it is minus 5 is there, right, and we have to again check in this case the like the best optimized of these two, which is the this is the because when we are dealing with -5, we have to check this column and this column. So which is the column 1 and 1 and 0 and 2. So -10 is there and again 0 is there. So which is the greater value? 0 is obviously greater than -10, right? So -5, which is the current position of the cell, plus 0, which will become -5. So this is how we are slowly like completing the table, since we have to move only towards the left direction or towards the top direction. That is how a bottom up approach works. Now come to this point. So we have this point as 3, right? And -4 is given. So basically 3 plus -4 is -1. So over here we are getting a -1 value, right? So again we have to go to this particular direction, which is this direction, which is saying where we have a value of -3, right? And we have two values, -1 and -10. So which is the greatest value of -1 and -10? -1, right? So -3 and -1 adds up to -3 plus -1 equals to this particular value will be -4. And lastly, we have two values, which is -2. So first what we're going to do is -2 plus the maximum of these two, -4 plus -5. So the -4 is the maximum, so we will get 6, right? So we will get a positive value of, sorry, we'll get -6, right? Now we have to return. What are we basically we are going to return? So let's come to the question. We are going to return, uh, our task is to, we can move across blah blah blah, minimum initial points to reach. So minimum initial points to reach is minimum initial points equals to this particular value, which is the last value. Because you can see, now you will ask me a question that why am I doing the addition in each and every cell? So in the question it is given, in the very initial it is saying that whenever we pass through a cell, points in that cell are added to our overall points. So similarly the overall points are being added. Okay, so -6 plus, so basically we will take the absolute value, so we can write it like -6 plus 1. So why 1 we are taking over here? Because initially whenever we are starting from a particular element, it cannot be 0. So initially the value has to be 1. Only then we can reach this -5, right? So which is equals to 7. Now you can understand very clearly that how is this particular 7 coming, because otherwise if you read the explanation, it is the minimum value to reach the destination. Yes, it is the minimum value. 7 points is the required minimum value from moving -2 to -5. But how we are going to do it? We are going to calculate each and every point like this in a bottom up approach, and then only we can do it. Now let's go with the problem. So the problem is basically saying in the lead code, let's understand what's there in the lead code, and you will be a bit interested even to solve this problem. So they're saying the demons had captured the, it's a dungeon game. So if you know, a dungeon game is like, demons are like the bad people. We have captured the princess and imprisoned her in the bottom right corner of a dungeon cell. So you see, lead code is definitely better than GFG because they have given an approach. So the approach which is saying is -5 is given over here. So -5 is basically what? The bottom right corner of a dungeon. So here you can see it's -5 is given, which is a bottom right corner of a dungeon. So basically our princess is hiding over here. जो प्रिंस है प्रिंसेस है वो यहाँ पे, like they have been captivated and they have been put over here. So now the duty of the prince is to flee her, right? Like this, in the old days we know that's how the game works. So if we see, the dungeon consists of m cross n rooms laid out in a 2D grid. So you can see this is an m cross n, these are all the rooms, and the particular way, like the king is over here in -2. So in what way the king can go to -5 and save the princess? That is the question basically, right? So let's see what it is saying. Our valiant knight was initially positioned in the top left. Yes, -2 is 0,0 at the top left and must fight his way through the dungeon to rescue the princess. So in each and every step of the way, the dungeon is like, the prince is going, the knight is going to face a lot of problems in order to like successfully evacuate and help the princess who is being captivated over here at -5. Similarly, we can say that the knight has an initial health point represented by a positive integer. So what is this initial health point? So initial health point is like, suppose I've taken 1 over there in the initial health point. So initial health point means like, whenever you used to play a game, right, we knew that whenever somebody kills us, our health decreases. So it's like, obviously if you have played any type of game where you are fighting with someone and somebody kills you, so your health decreases by 1. So similarly over here you can see that the knight has given an initial health point which drops to 0. So if by mistake the knight chooses such a path where the health becomes zero, that the knight will immediately die, right? So there will be no room for error, there will be no room for rectification and how the knight is going to save. So some of the rooms are guarded by demons represented by negative integer. So whether you can see like -2, -3, -5, -10, -5. So -5 is also guarded by a demon. Demon is like the bad person. And -10, -5, -3, these are all negative integers in a particular M cross N matrix. So they're all being guarded by demons. So you have to move in such a manner. You can see -3, 3, 1, 5. This is the shortest minimum possible way in which we can save the queen. So what is there? Some of the rooms are guarded by demons, so the knight loses health upon entering these rooms. Other rooms are either empty or contain magic orbs that increase the knight's health. So whenever the knight will encounter an empty room, health of the knight gets increased because it does not have to fight. It is saving his energy every time it's entering a new room, which is empty. So we can see that some of the room and the knight loses upon, and other rooms are empty or contain magic orb that increase the knight's health, right? To reach the princess as quickly, the knight decide to move only right or downward in each step. So this is how the problem has been analyzed, that we have to reach -5. So sometimes it will face the negative and it will lose its health, sometimes it will face the positive, it will gain its health, sometimes there will be empty rooms, it will gain its health more. And this is how the optimal path is like followed, which is in order to reach -5 from -2, it is following the path -3, 3, 1, and then -5, which is right, right, down, down. So let's go with the code explanation. The first code explanation is we are creating a min difference point function which has two parameters, an array and the size of m comma n. M comma n is basically denoting the particular, like the n comma n is basically denoting the particular size of the matrix. Then the 2D array has been initialized with the size of the matrix. Now we have to initialize the bottom right cell with minimum points needed. So what is the bottom right cell? The bottom right cell is -5. So right, so in order to initialize the bottom right cell, which is m minus 1, n minus 1, so we are doing this particular thing, points m minus 1, n minus 1, and we have written the formula and using the mat.abs value. So what is mat.abs value doing is we have been given two coordinates, right? Suppose in this particular question, -2, -4, and the answer is -6, but we can't return -6. We have to return the positive or the absolute value. So we are taking math.abs of -6 plus 1 in order to make it 7. So here what I have done is nothing but this only. Similarly, what I have done is calculate the minimum points needed for the cells in the last row. So in order to exclude this particular point and focusing on the other 2 points of the rows and column, what I can see is we are doing an approach which is taking math dot max of the down plus right. So what over here we are doing is math dot max of down minus right. So down, like down plus right comma 1. So basically it is basically taking as 1 as the initial matrix and math dot max dp I plus 1 n minus 1 points of I n minus 1. So first it is storing the current value in the dp, and points is like the initial matrix which we have given in the question. And similarly we are calculating, let's not dive deep into it. So it's how we are calculating for the last row, and for row we are using I loop and m for the size of the number of rows, and for last column we are doing a similar approach of math.max, or taking the maximum of the uh, adjacent and the down value, and we are doing it using j loop, and the j loop is basically also doing a calculation for the last column, and it is basically taking the math.max of this particular two things. Lastly, for the remaining cells or the remaining cells which are not being calculated, we are using this particular formula of the remaining cells of for the rows and column mat.main of dp of ij and ij plus 1, and we are like storing the minimum formula using the mat.mix of the exit points minus points. Lastly, what we are going to do is we are going to return the minimum points at the starting cell. So what is the starting cell? The starting cell in the dp table we have to find, not this one. So the starting cell in the dp table is 0 comma 0, and the value present is -6, and now we have to convert it into absolute value plus 1, and thus we are going to return the 7 over here in this statement. So this 7, you will say ki not, why not 6? Because these functions have individual points calculations, and in the point calculation what we are doing is we have to initialize the bottom right cell with the minimum points. So plus 1 will be there plus the dp of the points. So plus 1 is added in order to say that no cells are empty. Let's execute this particular problem statement. I've already executed this particular problem statement over here and compiled it. So this is how we have successfully completed 55 days of Geek for